Welcome to Classes with Atish. In today's lesson, we will continue with functions. The function that we are discussing today is polynomial function. This is one of the most interesting and most exciting functions in my opinion. But what is a polynomial? Let's just describe that first, okay? Okay, so the first thing, polynomial function is this: y equals a n x to the power n plus a n minus 1 x to the power n minus 1, and we continue with this. Let's say a 2x square plus a 1x plus a 0, okay, where ai is a constant, okay, n is the degree of the function, okay, an is not equals to 0, and n belongs to set of natural numbers, okay. So obviously the simplest polynomial function would be of degree 0, where we can say y equals a0, okay. So this is of degree 0. We can say y equals a1x plus a0. This is a polynomial function of degree 1. Y equals a2x square plus a1x plus a0 is a polynomial function of degree 2, and such, okay. So we'll discuss more about how each of these graphs look like and what would be the domain and range of each of these. Some are pretty obvious, but let's discuss that in detail, and soon we'll find out how interesting this function is. Let's talk about a few definitions. Like for example, we said degree of a polynomial, but what is the degree of a term? Any generic term, let's say this is one term we are looking at, the degree of the term is the exponent, okay. So we can write exponent of x, okay. Similarly, degree of the polynomial is the highest degree in the function, right? So degree of the polynomial, in this case it is n, okay. Now what is the leading term? Leading term is the term with the highest degree. So this is the leading term, an x to the power n, okay. So what is the leading coefficient? So all these ai's, these are coefficients. So leading coefficient is an, okay. A few other things I just want to point out. So a polynomial function has these properties. Number one, it's a smooth curve. It has no pointed ends on the curve, okay. Number two, it is a continuous curve. So there are no discontinuities on the curve. So which means it is defined for all real numbers on the number line. So obviously the domain of a polynomial function is the set of real numbers, okay. Okay, number three, the roots of a polynomial function are found out by finding the solution to y equals 0, okay. So it might have real roots, it might have imaginary roots as well. Not necessarily that all roots of a polynomial function will be real. Now, a polynomial function of the degree n or order n, sometimes it's called order, it will have n roots. Some of them could be real, some of them could be imaginary, but in all it will have n roots. One other thing, the sign of the leading coefficient, sign of the leading coefficient, which is an, this is important. Okay, this determines the shape of the curve. Okay, so with these, let's start to explore some of these polynomials of degree 0, 1, 2, and in fact we will talk about even higher degrees of polynomials, how to graph those. Okay, this would be a very interesting lesson. Okay, so the first function, y equals c. C is a constant. This is a polynomial of degree 0. This is pretty simple to plot. X-axis, y-axis. So y equals c will be a plot like this, right? As you can see, the domain is the set of all real numbers. So x can take any value, y is always c, and range is of course just the value c. Okay. Now let's look at y equals ax plus b. So this is a polynomial of degree 1. Okay. X, y. This one is also simple. So a gives you the slope and b gives you the y value when x is 0. Okay. So this is y equals ax plus b. So obviously this point is 0 comma b. We can say a equals slope of the line and b is the y-intercept. Okay. Alright. Okay. Now a polynomial with degree 2 is called a quadratic equation. Let's take one example. Y equals x square minus 2x plus 1. Okay. Just for simplicity, if we factorize this becomes x minus 1 square. Okay. Now, how would this graph look like? If we plot this graph, this is the x-axis, this is the y-axis. Now, when x is 0, what's the value of y? Minus 1 square. So, it is 1. When x is 1, what is the value of y? It's 0. Okay. When x is 2, 2 minus 1, 1 squared, what's the value of 1? Is 1. Okay, let's say x is 2, is 1, is 2, is 1. Okay. When x is 3, then the value of y is 4, right? So somewhere here. Similarly, when x is minus 1, so minus 1 is minus 2 whole square is 4. So it is like this. So if you plot this, this will be somewhat like this. Okay. This is actually the graph of a parabola. We'll talk more about that later on. But the shape of the curve is somewhat like this. In general, any quadratic equation, any quadratic polynomial, so this is a polynomial of degree 2 is called a quadratic polynomial. Okay, so any quadratic polynomial will be having a shape of a parabola. Okay. So in general it will be a parabola. Now it could be something like this. It could be something like this. Doesn't matter. But in general there should be the shape. Okay. Now a couple of things we must remember. Number one is this is a continuous curve. This is a smooth curve. Okay. There are no sharp ends like this. Okay. Okay. So there is no sudden change in slope. And roots of the curve is found out by equating y equals 0. So when y equals 0, the roots that we find out is 1. In fact, there are two roots and both are equal to 1. Okay. In this case, when we find y equals 0, in this one, let's say for graph number 1, graph number 2. So for graph number 1, you can see that y is never equals to 0. So that has imaginary roots. It does not have real roots. In graph number 2, you can see y equals 0 at this point and at this point. This has real roots. Okay, and maximum roots that can happen is equal to the degree of the polynomial. For quadratic polynomials, it is 2. Okay, so 2 real roots here. Now let's move on to cubic polynomial. Let's take an example. Let's say y equals x minus 1 times x minus 2 times x minus 3. So if we expand this, it is x cube minus 6x square plus 11x minus 6. Okay. Now this is called a cubic polynomial. Okay. Now to get to the graph of a cubic polynomial, always remember few things we have already learned. Number 1, it's a smooth curve. It would be continuous and its roots are got when y equals 0. What would be the roots of this polynomial? It would be 1, 2, 3. Okay. Now let me introduce another property or rule. Okay. Before we get there, let me show you why it happens. Let's try to plot this one now. This is y-axis, x-axis, minus y, minus x. Okay. So roots are 1, 2 and 3. So we know that these 3 points, x equals 1, y is 0, 1 comma 0, 2 comma 0 and 3 comma 0. These are 3 points that lie on this smooth continuous curve. Okay. Now we need to find out how the shape of that curve is. Okay. Now let's look at this example. When x tends to infinity, what's the value of y? Okay. How do we find that? Let's say we divide, we take x cube common. Okay. So this will be 1 minus 6 by x plus 11 by x square minus 6 by x cube. Okay. So when x tends to positive infinity, all these 3 terms, do you think they will tend to 0? Absolutely, right? And if x tends to infinity, x cube will very quickly tend to infinity, right? So when x tends to infinity, y also tends to infinity, but it goes like this. Okay, so it will be a sharp rise. So at least we know that the graph will end up like this. Okay. Now let's say when x tends to minus infinity, again these 3 terms would tend to 0. However, when x tends to minus infinity, x cube will tend to minus infinity as well, and very quickly. So which means x is negative here, y is negative here. This tends to minus infinity like this. Okay. So now that we know that the graph is smooth and continuous and must pass through 1, 2 and 3, these 3 points, and it must go like this. So is it easy to find out what's the nature of the graph? It will be some, okay, one other thing, when x equals to 0, let's write it down. When x equals 0, what's the value of y? When x equals 0, y value is minus 6. So we also know that this graph will pass through this point. This would be 0, comma, minus 6. Okay. These points are 1, comma 0, 2, comma 0 and 3, comma 0. Okay. Now let's draw the graph of this function then. So this function will go like this. It will cut 1, it will cut this, and it will go like this. Okay. So from this we can generalize this rule. If the leading coefficient, okay, if let's say leading coefficient or coefficient of x cube, if this is greater than 0, if coefficient of x cube is greater than 0 and n is odd, in this case n equals 3, right? Then the graph will always be going like this. Okay. Similarly, if coefficient of x cube was less than 0 and in this cubic polynomial n is odd, then the graph would have been like this. Okay. Okay, let's stay on cubic polynomials for a little bit longer and discuss a few more cases. What we already talked about is 1, this is a smooth curve, 2, this is continuous curve. Okay. Number 3, the roots are when y equals 0. Okay. Number 4, we said if coefficient of x cube is greater than 0, then the curve will look like this. Okay. Okay. Now let's look at a cubic polynomial like this: x minus 1 square times x minus 3. Okay. Let's draw the x and y axis, x axis, y axis. Okay. How would the graph of this one look like? First thing, let's find out the roots. So the roots of this polynomial are 1, 1 and 3. Okay. So 1 comma 0, 3 comma 0. So the graph must be passing through these 2 points for sure. And when x equals 0, what's the value of y? So this will become minus 1 square, which is 1, and this will become minus 3. So this must pass through the point 0 comma minus 3. Okay, so this much we know. The other thing is coefficient of x cube is greater than 0. So we also know that the graph will be going this way and it will be going this way. Okay. Now, if we try to draw a graph like this, if it passes through 1, 0, and it's a smooth curve, it passes 3, 0, there is no way it can go to this quadrant without crossing the x-axis again, right? So the only way we can draw this graph would be if instead of passing it through 1 comma 0, it touches 1 comma 0 and goes like this. Okay, so make sure this condition is satisfied. When there are repeated roots, there's an additional rule that you can keep in mind, which we can say number 5. So if roots are repeated even number of times, then the curve touches the x-axis. If it is repeated odd number of times, then the curve crosses the x-axis. Okay, so quickly maybe we can take another example. Let's say we have equation x plus 1 times x minus 2 times x plus 3. Okay, how would the graph of this function look like? Let's use this space and try and do it. Okay, x-axis, y-axis. What are the roots? Roots are minus 1, 2 is another root and minus 3. Okay. Coefficient of x cube is positive. So the graph must be ending here and it must be ending here. Okay. There are no repeated roots or basically odd times. So there is only each of these roots occur only one time. So the curve crosses the x-axis at these roots. Okay. So we can draw a curve like this. Okay, pretty simple. Okay, next one, let's look at a quartic polynomial. What's a quartic polynomial? This is a polynomial of degree 4. Okay. Now all these rules will still apply, except we will expand rule number 4. So coefficient of x to the power 4, if that is greater than 0, then how the curve will follow is this. Let's take an example before I establish this. Okay, let's take y equals x minus 1 times x plus 2 times x minus 3 times x minus 4. So this is a polynomial of degree 4. Okay. Now if we expand this, I'm not going to expand this, but let's say we can write it as x to the power 4 plus ax cube plus bx square plus cx plus d. Okay. If we take x to the power 4 common, then 1 plus a by x plus b by x square plus c by x cube plus d by x to the power 4. Okay. Now let's look at when x tends to positive infinity. Okay. What happens? When x tends to positive infinity, all these terms tend very quickly to 0, and x to the power 4 tends to positive infinity at a very quick rate. So obviously this function will end up here. Okay. Now when x tends to negative infinity, all these terms quickly tend to 0, but this term negative to the power 4 is still positive. This term very quickly tends to positive infinity also. So the kind of graph it will happen is it will end up in the first quadrant like this and in the second quadrant like this. It's a little different than how it happened for x cube coefficient. For x cube, it ended up in this quadrant and this quadrant. It's a little bit different here. So just remember that. In fact, we will expand this rule to say, let's say 4 star, if the coefficient of the leading term, which is also actually called leading coefficient, is positive, if n is odd, which is this case n equals 3, then the graph will be like this. If n is even, which is the case when it's a quadratic equation or a quartic equation, then the graph will be like this. Okay, this could be like this, this could be like this. Okay, so just remember this one. So with these 5 rules, it becomes very easy to plot the graph of any polynomial now. Okay, let's complete this one, how the graph of this particular polynomial will look like. X-axis, y-axis. What are the roots of this polynomial? 1, 0, minus 2 comma 0, 3 comma 0 and 4 comma 0. Okay. When x is equals to 0, how much is y? It's a minus number. Let's say minus 24. Okay. Now coefficient of x to the power 4 is greater than 0. Yes, that's true. Then the graph will end up here. Okay. And here it will end up like this. Now there are no repeated roots here, so let's try and finish this graph. So this will pass through this point, this will pass through this point, it will cut through this point, it will cut through this point, it will cut through this and go like this. Okay, so that would be the graph of this function. Okay. The other thing is, like we said, a quartic polynomial of degree 4 can have maximum 4 roots. So these are the roots 1, 2, 3 and 4. Okay. It could have less than 4 roots as well. Some might be imaginary roots. So we'll take some examples and show you when that happens. Okay, we talked about the domain of polynomial functions. And for all polynomial functions, the domain is the set of real numbers. But let's talk about the range of polynomial functions as well. Okay. So first is, let's see a polynomial of degree odd. Okay. And a polynomial of degree even. Okay. Let's assume the leading coefficient is greater than 0 and is odd, and here also the leading coefficient is greater than 0 and is even. Okay. Now we did look at how the graph of these two functions look like, but just to remind you, let's do that one more time. So a polynomial of degree odd, the leading coefficient is 0, will always end up in this quadrant and this quadrant. And a polynomial of degree even, leading coefficient is greater than 0, will end up like this. So depending on the value of n, it might have certain real roots or imaginary roots, but mostly the curve will be somewhat like this. And for polynomial of degree even, the curve could be somewhat like this. Okay. So now if you look at the range of this function, the range, it can take all positive values of y and all negative values of y. So range will always be the set of real numbers. However, here the range will never be the whole set of real numbers. It will be always a subset of real numbers. Okay. Now let's finish this lesson with some examples. Okay. Let's try to plot these curves. X minus 1 times x squared plus 1. Okay, this is the first one we'll talk about. And then the next one we'll talk about is, let's say, minus x plus 1, x minus 3 square, x minus 2. Okay. All right. You can take some time, maybe pause the video and try to plot this and then come back and see if you got it right. Okay, so this is a polynomial of order 3. So n is odd. Okay, coefficient of x cube is positive. So it will end up here, it will end up here. What are the roots? The roots are 1 comma 0. Okay, and the other root is, so let me write down the roots somewhere actually. The roots are 1, and then the other one is minus 1 root, which is plus I and minus I, where I is an imaginary number. So you can right away see that this does not have real roots, all real roots, okay, only one real root, and it passes through 1 comma 0. Let's also evaluate when x is equals to 0, what's the value of y? So when x is equals to 0, y value is minus 1. So this will pass through 0 comma minus 1. Okay. Now it's a smooth continuous function. It ends here, it ends in here like this, and it passes through these 2 points. So I think the only way you can do this is this. It looks like a straight line, but actually this is a curved line, and maybe we can put a little bit of curve here. It isn't a straight line for sure. Okay, now let's look at this polynomial. X-axis, y-axis. Okay, so first thing, what are the roots? Let's write down the roots of this polynomial here. So this is 1, 3 comma 3 comma 2. Okay, so the graph will pass through 1 comma 0, 2 comma 0, will also pass through 3 comma 0, or touch 3 comma 0. Okay, now when x is 0, what's the value of y? So minus 3 squared is 9 times minus 2 is minus 18. Okay, so it will pass through 0 comma minus 18. Now what's the coefficient of x to the power 4, which is the leading coefficient? So this is positive, but this one is negative. So leading coefficient is negative. So in that case, the function will end up here and here. Okay. Now all is remaining is to be able to join these points and see how we can make the function end up here. Okay. So there is a repeated root at 3. So which means it will touch 3 comma 0. It will not it will not cross 3 comma 0. So how do we do this? So let's first, the curve passes through this point, it crosses this point, it crosses this point, and it touches this point and goes down like this. Okay, so that would how the curve of this polynomial will look like. Okay, again this is quartic equation. It should have 4 roots. It shows 3 roots here because one of the roots is a repeated root. Okay, it could have maximum 4 roots, but in this case there are 3 real roots. Okay, last example and then we're done. Let's plot this polynomial. Minus 2, x minus 1, x plus 1 cube, x minus 2 to the power 4, x minus 3, x minus 5. Okay. All right. Okay, first things first, what's the order of this polynomial? 1 plus 3, 4, plus 4, 8, 9, 10. Okay, am I right? 1, 3, 1 plus 3, 4, 4 plus 4, 8, 9, 10. Okay. What's the leading coefficient? It is less than 0. Okay. What are the roots? Roots are 1, comma, minus 1, 3 times. Okay. Then this is 2, 4 times. 3 and 5. Let's verify this one more time. X equals 1, x equals minus 1 3 times, x equals 2 4 times, x equals 3 1 time, and 5. Okay. Now last thing is when x equals 0, what's the value of y? So when x equals 0, then we have minus, so this is negative, this is positive, this is positive, this is negative, this is negative. So 1, 2, 3 negatives and 4 negatives. So this is a positive number. Okay. So it will pass somewhere here. I did not purposefully calculate towards the number in there, but that's okay. So let's point those minus 1 comma 0. We have 1 comma 0, 2 comma 0, 3 comma 0, and 5 comma 0. Okay, and it passes through some point here. Okay, now this is a polynomial whose degree is even and the leading coefficient is less than 0. So the polynomial must end up here and here. Okay, now it crosses minus 1. So it will cross minus 1. It will, so 2 is repeated even number of times. So this, it will touch 2 comma 0. Okay. So the graph will be somewhat like this. It will cross this point. It will go through this. It will go through this. It will touch. It will go through this. It will go through this and go like this. Okay. So you see, if you remember those 4 or 5 rules, then it's easy to plot the graph of any polynomial of any degree. Okay. Hope this helps. See you in the next lesson.